Okay, we have done with Kant gaseous hypothesis. Now we will do the Laplace nebula hypothesis. Now, who was Laplace? Laplace was a French mathematician, and he has written one book called Exposition of the World System. In this book, he has exposed the world system, that is how the earth came into being. He wrote this book in 1796. This book has hypothesis called nebula hypothesis. Since this is hypothesis, this is also based on assumption like that of Kant's. All right. Actually, Laplace hypothesis something similar to Kant hypothesis. Kant hypothesis was criticized. All right. The concept was wrong. He was against Newton's law. So just to rectify his wrong concept, Laplace made his hypothesis. So Kant said, because of collision, there was a circular motion. He said nebula expanded, circular motion also increased. And because of collision, it produced heat. Because of heat, friction was created. As because of friction, they started to collide with each other. That's what Kant has said. Now, let's see. So Kant said because of collision, there was a circular motion which was impossible. All right. Nebula expanded, so circular motion also increased. That was also wrong because size increases, the speed decreases, and if the size decreases, the speed increases, which we have done in the first place in the Kant's theory. Collision of produces the heat. How can small gas particles collide? Yes, they can collide, but friction is produced, heat is also produced, but producing so much of heat is not possible. Alright, so the small particles of gas producing so much of heat is not possible. So, this is also based on nebula. So, Laplace said, this is also based on nebula, like what Kant has said. There were small particles which he called nebula. So, Laplace also said there were small particles called nebula. Alright. So, Laplace said cloud of gases in the same way. He said it was hot and it was in circular motion. Whereas Kant said it was cold and it was motionless. Whereas Laplace is telling that it is hot. These particles are not. What are these particles? These particles are hot. It is hot and it is a circular motion. It is a circular motion. That is what Laplace has said. Because of this concept of collision producing heat, already it was hot and they were colliding, so the criticism was corrected. So, how was the criticism was corrected? It was already hot and it was in a collision, it was in a circular manner. So, this criticism of Kant was corrected by whom? By Laplace in the first place. Kant said because of collision, circular motion is created. Because of collision, what is created? Circular motion is created. But Laplace said it is from the beginning only it was in a circular motion. So this criticism was also corrected. But what Laplace said? It was in a circular motion from the beginning only, not today. From the beginning when the particles was born, it was in a circular motion. So this criticism of Kant was also corrected by Laplace. So third one and the first one, that is the criticism, collision producing heat. And collision created circular motion, that was corrected by Laplace. Okay, so third one, criticism, nebula becomes nebula becomes big, circular motion also increases. So as the nebula expands, the circular motion also increases. Alright, so Laplace said because it is hot, and he said heat always travels from high temperature to a body of low temperature. Since it is hot, the heat always travels from high temperature towards a low temperature, body of low temperature. He said nebula is hot with respect to its surroundings. This nebula is hot with respect to the surrounding. That means the surrounding is much colder when you compare with the nebula. Alright. So the heat traveled from nebula outside to the outer surface. So the heat traveled from the nebula where to the outer surface. So once they started traveling outside, so what happened? The outer surface started becoming cold. This outer surface started becoming cold. So the heat is traveling from nebula to the outer surface. So because when you compare the nebula with the surrounding is much colder than the nebula. So the heat from the high temperature area is going outside to the cold temperature area. So these outer surface started becoming cold. So nebula contract. So what happens? The nebula got contracted. Over here, the nebula got contracted and the size got decreased. Whereas in the first place, what Kant has said, nebula expanded, circular motion increases. But over here, the nebula is getting contracted. Why? Because the heat is passing from here to the outer surface. Alright. So, what happens? Thus, as the size increases, the speed, as the size decreases, as it is getting contracted, what happens? The speed started to increase. So, it was moving very fast in a circular motion. So he corrected Kant's second criticism as well. So he also corrected whose? Kant's second criticism as well. Alright. So because of the centrifugal force exceeds the centripetal force, over here also the same thing. The centrifugal force is exceeding the centripetal force. The outer force, the force which is trying to move outside, is exceeding the force which is trying to come inside. So what is happening over here? Okay, so the outer surface becomes cold, whereas inner surface. So outer surface, so inner surface, when you compare the outer surface, it's very cold. The inner surface is still very hot. Alright. So centrifugal force was also there. So one ring got detached. So how many rings? One ring got detached. Whereas in a Kant's theory, we have said that one ring got detached. Later on, simultaneously, 9 rings got detached. But this is not the case over here, as one ring got detached, and from this one ring, 9 rings were formed. How many rings? The 9 rings were formed, and these one which was left over here formed the sun. That is according to Laplace. But, alright, so 9 rings, okay. In the course of time, they became cold, and this is how the 9 planets were formed, okay. And the nebula which remained over there formed the sun. So this is all about nebula hypothesis. Alright. So Laplace wanted to correct the criticism of Kant, but he too got criticized. He too did not tell from where the nebula came. Like, he too could not say from where the nebula came, like that of Kant. It was hot and did not tell why was it hot. It was hot, he said in the beginning, but he could not say why was it hot, and also did not give the reason why was it in a circular motion. So he was criticized. Alright. So nebula was hot. It was circular motion. Okay, but from where the nebula came, he too, like a Kant, could not say anything, could not give us the clear picture. Second one is one ring got detached. Alright. From there 9 rings formed, but could not tell why 9 rings was only formed. They could have been 8 rings, they could have been 2 rings, but why 9 rings were only formed? Reasons could not be given. He could not tell the formation of fixed 9 planets. Alright, he could not tell why only the 9 planets were formed. Okay, that is understood. Third criticism of Laplace was, okay, even if we believe that the 9 planets were formed from nebula which was in a gaseous form. So when it was in a gaseous form, so once it gets cooled down, the gas changes into liquid, isn't it? The gas changes into liquid, and when it gets more colder, it changes into solid. But he never mentioned about a liquid over here. And you know very well, the liquid matter cannot rotate around the sun because all the layers of the liquid cannot circulate at once. Some could have rotated. Some part of the liquid can rotate fast, some rotate slowly. So all these things Laplace could not explain, and he too was criticized. And later on, he was again rectified by other mathematicians and other scientists. Thank you so much.